Good morning, good afternoon, and good evening, depending on where you're joining us from today. Welcome to our next TechSparks uh, webcast. Let me just hand the ball over to Peter real quick. For those of you who don't know me, my name is Len Thompson, and I'm Broadcom's Mainframe Division Community Manager. I just want to welcome you to today's session. Before I hand you off to Peter, I just want to let you know that we are recording today's session, which is why your lines are all currently muted. If you have questions along the way, please use the questions box along the right side of the screen, right under the GoToWebinar control panel. We hope you have questions. We'll get through as many of those as we can during our time today. And if there are any that we can't get to, I'll make sure that the team gets the information they need to follow up with you after the fact. The replay of today's session will be posted out in the Broadcom Mainframe software community either later today or tomorrow morning. And the last thing for me is that we are always trying to ensure that these sessions are as valuable as possible. With that in mind, there's a quick survey that's going to pop up at the end of the session. I'd really appreciate you taking a few minutes to give us some feedback so we can make the next session even better. And that's all of my stuff today, so I'm going to hand you off to Peter, so take it away, sir.
Hello everyone, good morning, good afternoon. My name is Plavjanik and I'm glad that you could join this session. And I hope that you are doing well during these times and you are staying safe. I would like to talk about what programming languages are considered as modern today and show you a few of them, and mainly talk about their benefits and typical use cases, and also talk about my personal experience with using them. I will start first talking about me and my history. My name is Petr Plavjanik and I work as developer and software architect at Broadcom, and I'm working in the mainframe division, so I work with the IBM mainframes and operating system ZOS. And I'm located in Prague. I had the opportunity to work for a few years in the Chicago office of Broadcom, but 3 years were not enough for me to learn American accent, but I was able to learn a few programming languages during these years. The first programming language that I have learned was BASIC, and it was on the computer that you can see at the bottom. It was called ZX Spectrum, and my mother told me that I started to program at age of 6, but I don't believe her, but I started quite soon. And then I learned at the high school programming languages like Pascal, C, C++. And then later I started to develop web applications. So I learned PHP, SQL. And at the university, I also learned logical and functional programming languages, and later C# and Java. After the school, I have joined a company called Computer Associates that later was known as CA Technologies and then acquired by Broadcom. And I joined the mainframe division, so I had the chance to learn programming languages like Rex, high-level assembler, or COBOL. And at that point, after learning COBOL, I thought that I have enough of programming languages, that I know everything that I need. But I will be speaking today about other programming languages because there's much more than just what you can see on this slide. So what is it, a modern programming language? This is a quite broad term. I think it can mean anything to everyone. I will be focusing on languages that gained a significant popularity in the last decade, and on those that provided something new and different than others. And I'm very sorry if I have missed a programming language that you like or even created, because there is much more than those few that I will be talking about. I will be trying to focus on the strengths of these programming languages, and because I work on mainframe, I will a little bit also focus on their support on mainframe. So when I was deciding that what I will be talking about, I was looking at the propriety of those languages, because I want to use something that more people are using, and also about what these languages can provide to me and what I can benefit from them. So I was also interested in success stories around them and typical use cases, and what's the community around them, if it's easy to find answers to your questions, how the language is supported. And languages are not just about writing code in your editor, but there are tools for building, syntax checking, linting. So I was also interested in the tooling. And because I work on mainframe, not all the languages are supported day one on mainframe, so I was interested in that as well. Last but not least is personal experience that I had with some of them. So today I will be talking about 6 of them, and I would like to do a quick poll for you. So if you can answer which of these languages you have used before. I have omitted Python, which I think that most of you already used, so you can choose only from these 5: Rust, TypeScript, Swift, Kotlin, and Golang.
All right, folks, I did launch the poll. It looks like several of you have started to do it. We'll give it another half minute or so more of you can hopefully give Petr some insights into what you're using. Do about another 10 seconds or so. All right, and there's our results, folks.
I can see that almost exactly half of you have used TypeScript, so this will not be new for most of you, but there's for others, I think you will learn something about them. So I hope that at least one of them will be interesting for you. So one of the criteria that I have used was the popularity, and I tried to find some sources on the internet about them, and there's actually a lot of sources. And I think for each language you would find some survey that likes the language the most. But one of the surveys is Stack Overflow, which is done every year, and people can answer a lot of questions about their development knowledge and tools and languages. And one of the categories is the most loved programming languages.
You listen the webinar with Petr Plavjanik?
No, I can listen later.
Yeah, it's the recording link.
So one of the surveys is questions about most loved programming languages, and you can see that those 6 are among the top 10, and I was interested why some of them are so popular, like the Rust, which was winning this category for several years. So, and maybe you will hear the answer today. Another of the indexes of propriety is called TIOB, Programming Community Index, and this is not just answer to one question, but this is considering multiple sources, like their usage on GitHub and number of questions on various forums or numbers searches in the search engines. And you can see that two of the languages, Swift and Go, are growing. So maybe in few years, some of these modern languages will be at the top. Yeah, Python is already there, but this one is the oldest one. Just to show you how the code looks in those languages, you will see examples of a very simple task, very simple web server, which is just having one endpoint, and this will send a greeting, hello, hello. And if you provide your name, it will greet you. Otherwise, it will just return hello world. You'll see it in every language. And also, I did a very short performance tests for these applications to get some understanding of their performance. And on this slide, you can see, I think some of you recognize Python, which provides the most short example. If you want to see what was being done, so there is a web server. You can issue the request for greeting, and it will return just text. However, if you provide a parameter, the query parameter, it will greet with your name. On this right side, there's a performance tests, very simple performance test that's issuing requests as much as possible and then counting number of responses. So the first language that I will talk about is Python. It's not really a new language. Its origins start in 1991 when Guido van Rossum has published the first release of Python. But since then, the popularity of Python is steadily growing. And you could see that now it's among the top programming languages. In the last years, it gained a lot of popularity because of the use cases in data science and machine learning. I have learned Python quite late because I didn't want to learn new programming languages after I learned a lot of them. And it looked to me like a weird scripting language. But then I started to get the questions from a non-developer, my friend, that he was a building architect, still is, and he was asking about Python. And he asked me, yeah, you are a developer, you should know it. So I didn't want to be ashamed, and I was helping him with his project. And he was using Python to automate some boring stuff to draw some blueprints that he was doing. And then I started to like this language. A few months after that, my boss wanted me to do some project very quickly, and Python was very obvious choice for me for this project. And that's one of the reasons why Python is popular, is that it's very easy to use. The code looks simple. You can usually understand it if you have seen some other programming languages, and you can write new code quite easily. Especially non-programmers can pick it up quickly, like my friend, but also data scientists, or they are not really focused on chasing pointers, but they would like to focus on data science, so they like Python because it protects them from many problems. There is a lot of libraries that are easy to use, and you can achieve a lot without writing a lot of code yourself. Some people say that Python is slow because it's not compiled, it's interpreted language, but you can write the fast applications in it. And the parts of code which need to be faster, you can write them in a compiled language and call them from Python. And since it's here for some time, it's supported on almost every platform, including mainframes. One of the concepts which started to be used in Python, but now it's in every programming language, is a package manager. So in Python, it started to be popular and it contributed to the success of the programming language. And combined with open source, you can find a lot of packages that will save you a lot of time. So on the left side, you can see source code that you will write, and you would like to use some functionality that was developed by someone else, and that can be distributed in a package, and you can just import it in your code and use it. In Python, you need to specify those packages as dependencies, and originally you just put them into a file and then install them from that file. But recently, something that's called pip file has been created, and that allows you to specify the environment for your project better. The packages can come from the official Python package index, PyPy, that can be used by everyone, but you can also create your package indexes, for example, in your company, where you can have your own proprietary packages. At Broadcom, Python is used for many things. The one that I started use Python for internally, and it's for test automation. We have developed a lot of scripts for automating testing of mainframe applications. And if you know mainframe, there can be a batch or online emulator, and typically you can test DB2 or CAKES applications. So we have developed functionality that made it possible to test it easily, and that started to be popular not just among developers, but also for QA engineers that were not coding much before, but the Python was good for them because they could learn it and start automating our tests. And automation and testing is not the only use case for Python. It can be also used for machine learning, data science. Typically, it's also used to develop backend for web applications. Before single page applications were standard on the web, you could develop web applications and serve the different pages, for example, using frameworks like Django. The next language that I will speak about is TypeScript. That was the one that you know most about, but there was a half that didn't use it before, so I will spend some time on it. But before I can talk about TypeScript, I need to mention Node.js and JavaScript. Well, JavaScript is one of the most used programming languages. Almost every website is using JavaScript at some amount, and the modern web applications, single-page applications, they are developed fully in JavaScript or something that can be transpiled to JavaScript. And then thanks to Node.js, which is an engine that allows you to run JavaScript not just in the browser but on your server. So thanks to Node.js, you can write your backends for web applications in the same language. But Node.js and JavaScript are very versatile. You can use them to develop command line applications. Typically, if you develop some application in React or Angular, there is some command line interface that helps you to develop those applications, and that's typically also developed and runs on Node.js. And using Node.js, you can develop desktop applications using the Electron framework. For example, if you use VS Code, that's based on Electron, and Node.js, just JavaScript or TypeScript. Node.js itself is built on top of the Chrome V8 JavaScript engine, which provides very good performance because it has a just-in-time compiler, for example, like Java. So it's not really interpreted, but it's compiled before it's executed into native instructions. So the performance of JavaScript is, for example, much better than of Python code. And it has also package manager, npm, and the joke on this slide is about it, because there's really a lot of packages. So if you are interested in learning how Node.js originated and what motivated the author to do it, I recommend to watch his original session. The author's name is Ryan Dahl, and when he was very young, he created Node.js, and he speaks about why it was done. And basically, he wanted to create a platform for scripting of highly concurrent programs, and that was based not on threads but on non-blocking infrastructure. So in Node.js, you don't have multiple threads, for example, like in Java. But there's something which is called event loop. It allows Node to perform non-blocking IO operations. So basically, because JavaScript was designed as single-threaded, Node.js follows that as well, and it tries to offload the operations to the system kernel as possible. So if there are some incoming requests, it will not open a lot of threads, but it will try to do one by one. But whenever there's some operation or some operation that can be done in the background, it will offload it, and then it will continue in the event loop after the operation is finished. And this model seems to work better than the threading model because you don't need to have a huge thread pool. So I will not be talking about JavaScript today, but about TypeScript. So what's TypeScript? It's an open source language that was created 8 years ago by Microsoft, and it's a superset of JavaScript. Any JavaScript code is a valid TypeScript code, and you can add optional static typing to the code, and this is very useful for me. I really like it because I can define what are the types, and then the compiler of TypeScript can find a lot of problems before I will run my code. And TypeScript uses the new features from ECMAScript 6, such as classes. and it actually allowed me to use them before they were available in the browsers or in Node.js. And because of the static typing, the tools for IDs, for example, in the VS Code, they work much better because they can auto-complete much more things that are possible just in JavaScript, which is dynamic. But at the end, the code is transpiled by TypeScript compiler, transpiled into JavaScript, so it can run anywhere where you can run JavaScript in browsers or using the Node.js on your server. I have mentioned mainframe, and if you use mainframe, usually we are talking, you do it using interface which is called green screen or mainframe emulator. And it's called green screen because the default color for the text is green. And we are using Node.js in a project which is called Zoe, which tries to make access to mainframe easier and more similar to other platforms. So instead of having green screen, Zoe provides a command line interface that you can use on any platform and then work with mainframe. And Zoe also provides a VS Code extension called Zoe Explorer, where you can write your code in VS Code and work with mainframe as with any system. And also it provides a desktop interface. And the CLI itself was written in TypeScript and running on Node.js engine. And the same is true for the VS Code extension and the backend service and the UI. So if you want to see some code, this is the same example as the Python one with the web server, which is doing exactly the same thing, and it's using the Express.js web server web framework. And you can see it's also very light, and you can do it only in few lines of code. If you have ever developed something for Apple ecosystem, you should know Swift. I have learned Swift immediately after it was introduced because I always wanted to write an iPhone application, and I didn't want to learn Objective-C because it looked very strange. But once Swift was introduced, I started to develop an iPhone application. I thought that I had a very good idea, but I was not the only one, so it didn't sell much. But I at least learned Swift. It's one of the newest languages that I'm talking about, and it's very good, and I will show some of the features quickly. So one of the features is it's safer to use if you compare, for example, to C or C++. So you cannot use pointers as in C. So it prevents you to do a lot of problems. You cannot really have a null pointer exception as in Java, because you need to first unbox, unwrap the variable. So the compiler protects you, the language itself protects you from this. And all the variables are initialized, and it has a lot of checks and garbage collection. So another language is Golang. Sometimes it's called Go, but because Go is not very easy to use in Google, people are calling it Golang. And it has to be developed by Google engineers, Robert Giesemer, Pike, and Ken Thompson. And Robert Giesemer was student of Niklaus Werf, who has created Pascal. So there's some inspiration in Golang in Pascal and Modula, but it has to C-like syntax. And one of the most important principles in Golang is simplicity. So this language doesn't have many features, but they try to limit them to just few to make the language easy to learn. It's also its compilers are really fast, so it doesn't really seem that there's any compiler, and the code runs very fast. So there's a lot of things which are missing in the language. Yeah, if you already know Java or Python, you will struggle a little bit with that because you will miss a lot of things. But on the other hand, it's easy to learn. And if you are not developing all the time just in Golang, you'll find it very easy to switch to Golang because there's not much that can surprise you. And further, there's actually one feature which is not typical for programming languages to be built in such way as in Golang, and it's called CSP concurrency. And in Golang, this is achieved using goroutines. Goroutine is a function which can run concurrently with other functions, and there's a built-in mechanism for communication between those goroutines. So instead of using shared variables like shared maps or shared data structures, the goroutines can communicate using sending messages using channels. And in a complex concurrent programs, using messaging between the functions is more easily to be done correctly. So Golang is one of the newest languages, so it comes with a lot of tools which are built in the language. In older languages, those tools were added later, but in Golang and other programming languages that we are seeing today, the tools are built in, so you can. The build systems is in the language, the package manager, lot of tools like code formatter, or some testing framework. So in the language, you have everything that you need, and you don't need to choose between many alternatives like in Java. And I really like the gopher, the mascot of the programming language. So I'm trying to buy it for my baby, so he can play with the mascot and later with the language. Another interesting language is Kotlin, and if you know IntelliJ IDEA, it's made by the same company, JetBrains, and this language is for Java virtual machine. So at the end, it's compiled into bytecode, so it can run everywhere where Java can. And it's starting to be more and more popular, especially for development of Android applications. And last year, Google has chosen Kotlin as the preferred programming language for Android applications. And both JetBrains and Google provide support for this language, but it's open source, so everyone can use it. Good thing is that it's fully interoperable with Java, so you can gradually add it into your Java code without need to rewrite the existing code. The main benefit of Kotlin is that it was designed years ago, so they have learned from mistakes and from other programming languages. So on this slide, you can compare code in Java and in Kotlin, and the typical data class pattern which is used in Java, and you have either to write yourself or let the IDE generate a lot of code. Can for example, in this case, 33 lines can be written just in one. So you need to look into the code when you are writing some new code, and it has type inference, so you don't need to write types as much as in Java. You would say that newest Java has a lot of features like that as well. So, but Kotlin was designed from scratch, so it seems more cleaner and usable than Java. So the last one that I will be talking about is called Rust. And this one I have not really used much out of these programming languages. But it's interesting. I have interest in learning that because in the survey from Stack Overflow, it was ranked as the most loved programming language for many years, since 2016. So I was interested in why it's so. And typically people say that it's language which you can write very performant code, but it prevents you from making a lot of mistakes. Usually these things go against each other, but in case of the Rust, as the chart shows, it's a safe language, but it's close to hardware and you can achieve high performance. So, and it really seems to prevent developers from making a lot of problems. There's one new concept that it's different than other languages, and it's called ownership and borrowing, and it's enforced by compiler. So if you do it wrong, compiler will prevent you. But in other languages, that would lead to some big problem in the runtime. But in Rust, it will protect you. So each variable memory, it needs to have clear owner, and this owner can borrow it to other scopes, and it's going to specify what can be done. For example, the owner cannot free or mutate the resource if it borrows it to someone else. So this can prevent you from a lot of problems. And there's a lot of other features, but always in the Rust they try to design it in such a way that it's zero overhead, which means that it will not slow down the code which is not using the feature, and the feature itself is implemented in the best way, so you couldn't implement it better. So it doesn't have garbage collection because that would slow down everything, but still you can write good code in Rust. Just want to show you how the code in some of these languages can look like. I hadn't time to speak about Erlang. Maybe next time. And this is the same application, the web server, which developed in Golang. In Golang, there is no need for a special library or framework, because the standard library contains the production-ready web server implementation. In Kotlin, you can use everything it's in Java, like Spring and Tomcat, but in this case, this is using Petr, which was developed in Kotlin, and in Rust, this looks really most strange from all the languages. So if you are interested in the performance, don't look into these results. Yeah, you should use the link at the bottom about from Tech Empower, which provides comparison of performance of various web servers and frameworks written in different languages. So this provides better information for other platforms. I have tried to do some simple tests on mainframe, where these languages are also available, and you can see that on GeoS itself, Golang was the fastest one, and Java has a very good performance on mainframe as well. TypeScript the same, and Python itself is not very good for web servers. It's usually used with some real HTTP server like Apache on Nginx, and it doesn't really implement the web server. So on this slide, you can see some summary for the strengths of languages that I was speaking about, and there's also the list of typical use cases where you can use these languages. And I have a question, another question for you about what language out of these that you have seen today would you like to try for your next project?
All right, folks, once again, I have launched the poll, so if you can give us some feedback, that'd be great. We'll keep it open for about another 30 seconds or so. All right, I'm going to go ahead and close that poll and share the results.
So I can see that you are mostly interested in Kotlin and Golang, and also Rust. Swift is the latest one. I think I forgot to mention that you can use Swift also not just for development on Apple platforms, but Apple has open source Swift recently, and you can also use it to write applications on Linux. It's starting to be popular among the developers to create the backend services, usually for the Apple applications which are running on Apple devices. Thank you for your answers, and can conclude this session. So you can see that you have a lot of choices today. It's not very easy to pick up the programming languages. It's not about using the latest and greatest language, but you should always focus on the problem that you are trying to solve and then choose the programming language for it, not the vice versa. But learning programming languages is fun, and you can always learn something which will help you to be a good developer. And if you want to learn of some of these programming languages, and for example, you would like to learn something when you commute and you don't drive, or on the beach or whenever, you can use this application. It's called Playground, and it's iPhone or iPad application. And there are similar applications like that for Android as well. And in this application, you can find very simple examples in each programming language of the main basic features of these languages. You can even develop something and run it directly on your phone. So I was using it to learn it a little bit about each language, to familiarize myself with the syntax and the main features. So that's everything from me. I hope that it helped you to choose a programming language for your next project. And now we have some time for questions if you have any.
Thanks, Peter. Just a reminder, folks, please do use the questions box right in the go to webinar control panel. We do have one question already, so I can go ahead and read that. Could you please suggest any forum where I can see applications that are developed using Python or Node.js connecting ZOS files? I would like to understand how I can use these new languages in my project for faster execution of jobs when using huge files.
Yeah, I think it would be best if you can contact me using my email after the session, and I can provide you more details. If you want to start using with some of these programming languages on mainframe, I think I have prepared a lot of tutorials about them, which can be found on the platform called Medium. And if you will Google for Medium and my name, you can find them. Or if you send me an email, I will send you the links.
Thanks, Peter. After the fact, I can also send you the attendee report, and I can highlight the person who asked that question as well. Are there any other questions, folks? Give everyone another minute or so to type if they need to type. And I'll take this chance to also remind you that we are going to show you a survey when I close the session down. So if you could give us another minute of your time, it's just 5 or 6 questions, real quick, real easy. Just make sure that we can, just make sure we understand what you thought about today's session. I don't see any more questions coming in, so I guess we can go ahead and wrap up. As always, thank you, Peter. I'm actually going to take control back just for a second.
Thank you, Len, for hosting, and thank to all of you for listening and attending this session.